On July 1st, 2025, a survey telescope in the mountains of Chile caught a faint object streaking through the sky that should not exist by any normal reckoning of time. When astronomers finally worked out its age, the number stopped them cold. Somewhere between 10 and 12 billion years old, a wanderer that was already ancient before our own sun had even finished forming. It moved faster than anything ever recorded entering our solar system, and within weeks, one of Harvard's most prominent astronomers was publicly asking whether it could be artificial. NASA pointed the James Webb Space Telescope directly at it and got a real answer. This is what they found. For nearly all of recorded human history, every comet, asteroid, and wandering rock ever observed in the night sky belonged to our own solar system, born from the same swirling disk of dust and gas that formed the sun and planets roughly 6 billion years ago. That changed permanently on October 19, 2017, when the Pan-STARRS telescope in Hawaii spotted a small, fast-moving object later named Oumuamua, the first confirmed interstellar object ever detected passing through our solar system. It generated global fascination and their endless speculation, then vanished from view within months, too small and too faint for any telescope on Earth or in space to track any further. 2 years later, in 2019, a second interstellar visitor, comet 2I Borisov, arrived and behaved far more like a familiar, ordinary comet, easing some of the mystery but confirming that these visitors from other star systems were not a one-time fluke. Then, on July 1st, 2025, the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, caught sight of a third one. Astronomers confirmed its interstellar origin within a single day, and it was given the formal designation 3I Atlas, officially cataloged as Comet C 2025 N1. From the very first days of observation, it was clear this object was going to be different from its two predecessors in almost every measurable way, and unlike Oumuamua, this time humanity actually had the instruments in place, including the James Webb Space Telescope, to study it properly while it was still there to be studied. The moment researchers calculated 3I Atlas's trajectory, its numbers immediately set it apart. It was found to be moving through the solar system on a strongly hyperbolic orbit with a velocity at infinity of roughly 58 kilometers per second, close to 130,000 miles per hour. To put that in context, Oumuamua moved at about 26 kilometers per second, and Borisov at around 32. This third visitor was moving nearly twice as fast as either of the objects that came before it, and researchers determined its orbital eccentricity to be extraordinarily high, around 6. 1, a number so far beyond a value of 1, which would represent a barely hyperbolic escape orbit, that there was no ambiguity at all about its extrasolar origin. This was not a solar system object that had simply been flung onto an unusual path by a close encounter with a planet. This object came from somewhere else entirely, and it was moving with a speed that immediately told astronomers it must have been traveling through interstellar space, completely unbound to any star, for an extremely long time before it ever crossed into our solar system's territory. Its physical size also set it apart. Early observations using the Hubble Space Telescope constrained the object's effective nucleus radius to somewhere under 2 and 8 kilometers, while separate observations from the Vera C. Rubin Observatory suggested a radius closer to 6 kilometers, a real discrepancy between instruments and methods that researchers are still working through, but even the lower estimates make 3I Atlas substantially larger than either Oumuamua or Borisov. Researchers attempting to pin down its rotation period ran into genuine disagreement as well, with some teams reporting a rotation period near 79 hours, others measuring closer to 16 hours, and still other research groups failing to detect any clear periodic rotation signal at all in their own photometric data, a reflection of just how difficult this kind of measurement is for an object this distant, this faint, and this fast-moving. The single most staggering finding to come out of the 3I Atlas observation campaign involved not its speed or its size, but its age. Using dynamical modeling based on the object's trajectory and kinematic behavior, researchers led by Taylor and Seligman estimated 3I Atlas's age at somewhere between 3 and 11 billion years. And follow-up analysis using James Webb Space Telescope data in 2026 refined that estimate further, placing the object's likely age at somewhere between 10 and 12 billion years old. Our own solar system, by comparison, is roughly 6 billion years old. This means 3I's Atlas likely formed around a completely different star, one that existed and died long before our own sun ever ignited, making this object a genuine physical relic from an era of the universe astronomers sometimes refer to as cosmic noon, a period roughly 10 billion years ago when star formation across the universe was at its most intense and prolific. Researchers studying the object's composition found something that reinforced just how ancient and well-traveled it truly is. A 2026 study examining the comet's surface chemistry found strong evidence that its outer layers have been substantially altered by prolonged exposure to galactic cosmic rays, the high-energy particle radiation that constantly streams through interstellar space. The research team's conclusion represented a genuine shift in how scientists think about long-duration interstellar objects. Rather than arriving in our solar system as pristine, untouched samples of the star system that originally formed them, an object that has drifted through the galaxy for billions of years, as 3I Atlas clearly has, would have had its surface chemistry fundamentally reworked by radiation exposure long before it ever entered our neighborhood, meaning what scientists observe on its surface today tells a story about billions of years of cosmic wandering as much as it tells a story about the object's original formation. Given an object this old, this fast, and this unusual, it was perhaps inevitable that speculation would eventually turn toward the most extraordinary possible explanation. Harvard astronomer Avi Loeb, who had previously drawn significant public attention by suggesting Oumuamua's strange, unexplained acceleration back in 2017 and 2018 might indicate artificial origin, once again raised the possibility that 3I Atlas could be something other than a natural object, pointing to its unusual trajectory, extreme age, and specific orbital characteristics as at least worth serious scientific consideration rather than immediate dismissal. That kind of speculation from a tenured astronomer at one of the most prestigious universities in the world was never going to stay confined to academic journals. And it didn't. Coverage of the alien spacecraft hypothesis spread rapidly across news outlets and social media throughout late 2025 and into 2026, turning 3I Atlas into one of the most talked about objects in modern astronomy almost overnight. But the response from the overwhelming majority of the scientific community was consistent and unambiguous from the very beginning. Researchers across multiple institutions pointed to the growing body of direct observational evidence, spectroscopy, imaging, trajectory analysis, all of it consistently describing the behavior of a natural comet, not a piloted or artificially controlled object. A comprehensive SETI search, specifically targeting 3I Atlas for any sign of radio transmissions, the kind of signal an artificial craft attempting or capable of communication might produce, returned a definitive result. 0 technosignatures detected of any kind. This is where 3I Atlas's story diverges completely from Oumuamua's, and where real, current, hard scientific data takes over from speculation entirely. On August 6, 2025, just over a month after the object's initial discovery, the James Webb Space Telescope turned its near-infrared spectrograph instrument directly at 3I Atlas and began collecting real spectroscopic data, something that was never possible for Oumuamua because it had already faded from view years before Webb ever launched. This time, humanity actually had the right instrument, pointed at the right target at the right moment. The results, published in the journal Nature on June 22, 2026, by a research team led by Martin Cordner at NASA's Goddard Space Flight Center, revealed a genuinely bizarre chemical signature. The comet's coma, the cloud of gas and dust that surrounds an active comet's nucleus as it's heated, showed a methane-to-water ratio roughly 11 times higher than any previously measured object in the solar system, an extraordinarily unusual proportion that immediately stood out to researchers analyzing the spectral data. Rather than pointing toward anything artificial, however, the research team determined this striking chemical signature was fully explained by natural thermal outgassing processes, specific chemical and physical reactions triggered as the comet's ancient ices were heated by solar radiation for the first time in what may have been billions of years. The same study measured the object's deuterium to hydrogen ratio at approximately 0. 98%, a figure NASA and the European Space Agency noted, is roughly 30 times higher than typical solar system values, another data point consistent with an object that formed under very different conditions, around a very different star, an extremely long time ago. Taken together, the direct observational evidence assembled by Webb, Hubble, the Rubin Observatory, and numerous ground-based telescopes around the world builds a coherent, consistent picture. And it is a picture of an extraordinary natural object rather than anything artificial. The comet displayed a consistently reddened spectral slope, similar to D-type asteroids and consistent with both of the interstellar objects observed before it. Multiple independent research teams confirmed cometary activity through direct spectroscopic detection of gas emission, the telltale signature of a genuine comet actively outgassing material as solar heating vaporizes its surface ices, a process fundamentally different from anything that would be expected of an artificial, engineered spacecraft. As one widely read astronomy publication summarized it directly in 2026, Following the release of the JWST age and composition data, the overwhelming scientific consensus effectively closed the door on the alien spacecraft hypothesis, even as public fascination with the idea continued to circulate widely online. The vast majority of practicing astronomers and planetary scientists studying the object have been consistent and unambiguous. Every piece of direct physical evidence collected, its chemistry, its outgassing behavior, its spectral signature, its total absence of any detectable radio transmission, points toward a natural comet, one made genuinely extraordinary, not by artificial origin, but by its almost incomprehensible age and the sheer distance and duration of its journey through the galaxy, before crossing paths with our solar system at all. Throughout its passage through our solar system, 3I Atlas followed a trajectory that took it past Mars's orbit around early October 2025, close enough that multiple spacecraft currently operating around Mars had a genuine opportunity to observe it directly. It reached its closest approach to the Sun, its perihelion, in late October 2025, at a distance of roughly 36 astronomical units, and passed behind the Sun from Earth's perspective, before becoming observable again as astrometric tracking resumed on October 31st, 2025. Throughout this entire period, the comet never came closer to Earth than about 8 astronomical units, roughly 270 million kilometers, meaning it was never anywhere near a threat to our planet, a detail confirmed repeatedly by NASA throughout the observation campaign, specifically to head off public concern. As of 2026, 3I Atlas remains observable even through smaller amateur telescopes in the pre-dawn sky, though NASA has indicated this visibility window is expected to close sometime in spring 2026. The comet passed Jupiter's orbit in March 2026, continuing steadily outward, and it is now firmly on an escape trajectory, meaning it will never return. Unlike objects native to our own solar system, bound to the Sun by gravity and destined to swing back around on a predictable orbit, 3I Atlas came from beyond our solar system entirely, and once it departs, it will continue outward into interstellar space permanently, never to be observed by human instruments again, exactly as Oumuamua and Borisov did before it. Here is what nearly a year of direct observation, using some of the most advanced instruments ever built, actually confirmed. An object that likely formed around a star that lived and died before our own Sun existed, spent somewhere between 10 and 12 billion years drifting alone through interstellar space, its surface slowly reshaped by cosmic radiation over that unimaginable span of time, before crossing paths with our solar system for the first and only time in its existence. It moved faster than any interstellar visitor recorded before it, carried a chemical signature stranger than anything previously measured in any comet, and briefly reignited a very old question about whether we might not be alone, a question serious researchers took seriously enough to search for radio signals and came back with nothing but silence. What Webb actually saw, in the end, was not evidence of visitors. It was evidence of something arguably just as extraordinary, a genuine physical piece of the early universe, aged and weathered by billions of years of galactic travel, passing silently through our neighborhood for a few short months before continuing on a journey that will now never end and will never be witnessed by us again.